I kind of do like the idea of a kind of a check-in system there, where as you spawn objects, they get a number, and that's their offset from their original position. And then you basically just make sure that every object that you want sorted there spawns with, it spawns on a track, as opposed to spawning in an infinite mathematical space between 0 and 10. It spawns always at 10, and it's got its offset, and it's just baked in. So the order of instantiation means that objects spawned later do stuff. And what you do when you move your object is you don't move it from, to move it forward, you don't like set its position forward. You move it to the next track and then add your offset in there. So instead of placing objects on the track based on their x coordinate, we would be placing their objects based on their track value. So it would be like, put me in this layer, as opposed to setting your x coordinate and do all that. So if we wanted to go that route, as opposed to the big mathematical data structure sorting monstrosity, just doing the actual, just to hell with it, do the simpler solution, and don't worry about it. Because the other thing here would be like, this would need to be 10 million units, 10 million objects would need to be spawned in the same track, not just, the same world. And 10 million objects or whatever is not really a big deal. You're not going to have 10 million fat sacks running around, guaranteed it. So there's of course another complication with this, which is if we had one object cross into another offset layer, we would want to I'm trying to think about it. Like, if we had, this mathematical offset that we just added, and we cross from one layer to another, let's say it's an analog system, and we can just freely cross between layers front to back. If we go if we do it on a global level, then there's only one object on that layer that you would collide with, and you would collide with it only during the exact frame where the value of your x was identical to the value of their x. And that frame would not be something easy to accomplish. Like, if you were actually moving from one layer to the next, you would have to, that offset would have to be the same. And it's not like setting, like my position to 2 or something. Let me see, is there a way to... Like, what I'd want to do is I'd want to actually render the object at a different location based on their offset value, perhaps? Like I could actually have the exact same X value, but the depth would be slightly different. Like I could go into the material for the sprite, and we could have a pixel depth offset, which gets passed in from the component, maybe? That would be interesting. So we might be able to use the pixel depth offset. And we might just be able to do, the naive, you get a little number, and that number's the same. It's an interesting thought. Well, why don't we try it out then? So what we're going to try is we are going to make it so our paper sprites and paper flipbook components inherit from a parent component, and on spawn that component uses it's going to get an offset. And how do we compute that offset? Do components have a unique ID or something else that they could use that's always changing, or something that we can use as a counter? Let's see if things have a component ID. So class used to identify primitive components. There is a f primitive component ID value. So primitive components do have component IDs. We could do that. Alright, this would be really funny if I want to be able to pass in a custom value to this thing. How does this? This is a texture sampler 2D with a special automatically defined parameter name. Because what I'd like to do is I'd like to pass in the primitive component ID to the material itself and just add that as a pixel depth offset and divide it by something. Because that could just magically work, which would be pretty cool. So let's see. I need to Google pass variable to material Unreal. Making material parameters. Material parameters, special kind of material expression nodes allow you to change the look of material without recompile the. Let's see. Simplest way is to make a material parameter out of a material expression. Right click on the material expression node and choose convert to parameter. Can we just do parameter? Is there like constant? Is there like convert to parameter? Parameter name is depth offset. The group, no group. Default value is 0. I mean, can I define what this is? I guess it's a float. That's just what it has to be. So like, how do I set this thing? So there's like set material parameter is a function. So let's see if we go to like, this is the masked lit sprite, and this is using the masked lit sprite. If we go to the rock, I mean, there's like set material parameter, but it's like a material interface parameter name. But this only works for the particle system. I want to just set it on a material. So like, I want to like get the material itself off of this. So it's like get the paper sprite. Alright, so like get component by class. Paper sprite component. And we want to get material. Let's see, how do we set a parameter? Set material parameter. We have to make a dynamic material. Is a thing. That's actually a thing. So is there like stats or? So material instance, let's see, instance parameters? Target is material instance dynamic. Alright. Alright, material instances can be calculated at runtime. Material instance, set its parent, creating parameterized. So we need to make this thing dynamic. How do we make it dynamic? That means you can place material instance dynamic are created within script either from a parameterized material or a material instance constant in Blueprint. One could take a given material that has parameterized properties and feed it through a create dynamic material instance node. Alright, so what we have to do for these boulders is we have to call in our construction script. Dynamic material instance. Target is, source material is Dashkin masklet sprite. Alright, so if we have a dynamic material here, so we're going to grab the material off of the primitive component, and then we're going to call set texture parameter value. And this parameter name is called depth offset. It's not texture parameter value, it's a set scalar parameter value. Why were there two of these? Yeah, okay, that's better. So it's depth offset. And we're going to set it to the primitive component. Alright, well, we should just be able to set this just like that, and we need to get error. This blueprint is not a primitive component, therefore target must have a connection. Like this. Alright, good. Well, I'm learning stuff. This is how we make an actual dynamic material. You do it at runtime, which is pretty cool. I didn't know you could do that. And also not very intuitive. I would have thought I would have made like a dynamic material, you know, inside of an asset, not inside of, you know, quote unquote code. So I need to get this like specific offset value here, and why don't we just hack it in for now? So let's just do math. Let's just do that, and we'll see if it works. Well, it looks like we're getting values. Let's take a look at this pixel depth offset. Let's make a really big value here, like random floating range. Let's just do 0 to 100, just to make sure it's actually doing what it should. So I mean, theoretically, that just solved our sorting problem. Like the depth offset is obviously all sorts of screwed up, but we're not changing the world position. We're just changing the screen space. You know, like the render frame stuff. Like every single one of those objects is like this. They're right on top of each other and all that. We also have the interesting thing there of are these objects at 0? And is our player at 0? Yeah, Bitey is at 0. Okay, so Bitey is in the same vein as these rocks, and they're getting placed. So the idea is, how big of a gap do I need here? Is Bitey going to draw behind any of these objects? Yeah, I don't know if you can see it too well, but there is Z fighting going on there with that log. Like as I move right there, and then I move farther over, the depth offset is wrong. So what I don't want a pixel depth offset. I want a vertex offset. So, okay, so it's like create vector, make float 3, and we want this depth offset to be the x direction, and this is what am I doing? I can just plug it into both. So this should actually change our world location when we draw it by 100. Which is totally different from our pixel depth. So yeah, we're not seeing the horrible issues that we had earlier. I'm wondering why Bitey is drawing in front of these guys, because we want like a negative 100 and 0 maybe. I just want to see one of these rocks draw in front of Bitey. Yeah, okay, so that's correct. That's what we want. Awesome. So okay, this is how we're going to accomplish this. Is we're going to use a material with a world position offset, which is going to be our sorting offset, and we need to basically set this parameter for our material. So now we need to find a good way to do that, and that's going to solve a hell of a lot of problems. Like, we don't have to hang on to some crazy world position and figure out if we've like moved or not, and then figure out where we should be. We can just do material stuff and have it work properly. Awesome. This is pretty cool. So let's think for a minute. Do we already have everything we need to do this? Like, I think the primitive component ID probably would be what we want to use. Class used to identify primitive components on the rendering thread without having to pass their pointer around to make it easy for people to access game code variables from the rendering thread. So let's take a look at the... I think I should just make a static function that's get primitive component ID, because it doesn't look like it's available in Blueprint. So let's go to primitive component.h. Let's look for f primitive component ID, and yeah, it's not visible to this thing. So let's take a look at what it actually is. So let's go to the declaration of it. So it's just primitive ID value. How does it actually get calculated? Because if this gets calculated in just like an incremental value, then yeah, okay, so component ID is it's just next component ID dot increment. And what is next component ID inside of the... It's a thread safe counter. Alright, so this thread safe counter is just going to be... This is the thread safe counter only for primitive components. So it is a... let's see what this says. It says it returns an int32. So we're going to have 2 billion values. So we can totally get this off of this. Is this a public thing here? Yes, it is public. All right, so if we just go to our object utils, we've already got something that says get unique ID. What we want to do is get primitive ID, and we want to pass in a U primitive component pointer. So yeah, if we can avoid making that gigantic system that we were discussing earlier just by using this, I mean, regardless, using this instance material stuff is obviously a much better idea. But if we can get away with this, then that's a lot of time that I don't have to spend working on crap. Alright, so this will get our primitive component ID value. Cool, so let's compile that and see what we can do with it. That is pretty cool though, that learning stuff about materials that I did not know. Because that was one of the things that I needed to kind of figure out, because we're going to be using normal maps and everything like that, is how exactly do we create materials which take input parameters. Alright. So we've got this set up there. Let's go to our rock blueprint. And we want to call get primitive ID. Target is Dashkin object utils, and we need a component. So we need the component right here. And what we need to do is a modulus. So what we're going to do is we're going to grab that primitive component ID. We're going to mod it by what is that, 100,000, and then we're going to multiply that by we actually want the so copy a piece of crap. There we go. So this will grab our primitive ID, and then we just multiply that by, we mod this, large number, and then we multiply it by that, and that should, we'll see if that's enough. Well, I don't see any Z fighting. Interesting that I actually do see Z fighting there. That is really fucking weird. So I guess that's too small of a number. So this is 10,000, and then so we could have 10,000 overlapping objects, and they wouldn't Z-fight, is what it looks like. At this distance, at least. So what we need to do is we need to zoom the camera out and see if the see if it fights at this level. I think I saw a little bit earlier. Yeah, see, there is a little bit of fighting going on there. Alright, so maybe we can't go with 10,000, maybe we have to go with like 5,000? So let's actually throw a constant here. Like, it's kind of stupid that I can't actually, like, just place a number. Like, I just want a frickin' int, you know? Like, make literal int. Okay, Jesus Christ. Okay, that's better. So we want maybe like 5,000, and then we want like divide. So this is how many subunits that we can actually get on our objects. Well, I don't see any fighting there. So 5,000 seems like a pretty good number. And the cool thing is, like, yeah, you can see it still screwed up in the editor. You can just place a whole bunch of shit here. Yes, that's with 50,000, so it's really that 5,000 is working out pretty well. Well, in order to actually merge those assets, I mean, the big point is we just don't want to have to, you know, walk on eggshells to throw content in the level and have it freak out on us. Because we can always just go in here and hand move stuff, and that's not a problem. So, but I think that's basically all we need. Is we just need these scalar parameter stuff running in here, and we need all these things using dynamic material instances. Well, combining it into one object would mean that you'd actually need to create geometry if they literally were like the same thing to prevent seams and everything. And that's not something Unreal can do. Unreal doesn't have like static mesh stuff. We'd have to like make something that dynamically created different, well, not dynamically, but statically, like as part of your level, like load or something, or level save or level load would merge assets together, and it'd be messy and would not work as you'd want. We're just gonna sit here and blow up the log. I just think that's so cool. We actually got the lighting and shadows working, so he's in shadow up there, and then he's not in shadow in here. Because when Adam had tuned this character, he was tuning it for using your Xbox controller. So you could kind of control how fast you wanted to do stuff. And when you're playing on keyboard like I do, because having an Xbox controller out the whole time is just a giant pain in the ass, the controls are not very good. And that's just also the movement. We need like a lot of like movement acceleration stuff on there, and we want a lot of other cool stuff as well. Like for instance, you know how Sonic is super fast, right? And if you like start running a Sonic, like he starts getting momentum and then, you know, speeding up and all that stuff. But, you know, there's one thing there with Sonic is you can start going really quick from rest. You know, he has problems getting momentum up from being completely stopped. And to solve that, they have like, you know, the spin dash and stuff like that, so you can just like quickly get speed and all that. And Bitey's probably going to have something similar to the spin dash, where we'd have like maybe some button, like you're running and then like you hit the go faster button or something, and then Bitey speed jumps very quickly, you know, so you wouldn't have to like hold down the run button or something, but maybe if you're running along and then like you hit the B key or whatever the hell, you know, he jumps forward like Bitey does and starts, you know, knocks him into, you know, a higher gear. So he's like on like gear 1 and he's running and sauntering and everything, no matter what you're doing with the thumbstick or the keyboard. And then like you hit the button and then he switches into gear 2 and starts running a lot faster and stuff like that. We'll probably do something like that, but we have to experiment with it. And right now it's just shit movement at the moment. All right, so we figured out what we need to do to figure out our Z fighting stuff, and it has to do with creating dynamic material instances in the constructors for our objects. And we can do that on begin play for our paper sprites and paper sprite components. We could do that for everything. And since this is a creation time thing, the question would be, how do we actually control this? Is there something that we should do to change this? Should we do it for everything, every value, or should we do it in the entities or in the effects or in something else? Like, I don't want to do this in blueprints all the time. I'm thinking I just want to throw it inside of the components themselves there. But I don't want to make a dynamic material reference thing unless there's a reason to. But the question would be like, what's the performance cost of dynamic materials? So dynamic material performance cost, Unreal. Performance cost of material, dynamic material instance. Let's take a look. I figured whenever I create one, a new material is made. Alright, so a dynamic material instance should be created in the construction script of an object it will be applied to and have the result of create dynamic material. Note, once that occurs, it can be update. Because you created the use of the DMI variable, you are not creating a new instance type each time you make a change. The performance is not an issue. It will be nearly as fast as using a normal material instance. Will not increase the number you mentioned in the original post. Okay, so I think we need to just do in the begin play. We need to just call this crap from our functions. So let's crack open exactly how the create material instance thing works. And I guess we don't have to do the begin play, we can just do the other one. And the chance of our objects right now having identical material instances is 1 in 5,000, or offsets is 1 in 5,000, and that would be from an object made across the map having the exact same slot as another object, which probably will never ever happen, because they'd also need to have the same track. So I'm just not going to worry about it. We can make a more complex system later if we need to, but who gives a shit, right? So if we go to this rock, I need to go to its blueprint editing thing. And it's called create dynamic material instance. So it's on the primitive component. Alright, so create and set, create dynamic material instance. It's right here, element index, source material, and then we have a U material instance dynamic.